Okay, starting on page 477 in your math book, we are going to talk a little bit about rotation. And the only kind of rotations we're going to work with are the kind that are around the origin. Just like we talked about in one of the problems of the day the other day, how this is kind of like the sun and our planets orbit around the sun. Our solar system kind of rotates around the sun. That's what we're going to look at today. Is this is going to always stay still, and the shapes are going to rotate around. So we have three different rotations we're really going to be working with, and we're going to be working with a 90-degree rotation, or a 180-degree rotation, or a 270-degree rotation. Okay, and I want to point out that rotations are shown. The rotations that are shown are clockwise. So in other words, clockwise means they're going this direction. Okay, the way the clock goes. Okay, so I want to talk about the words. A rotation is a transformation around a fixed point. In this case, that fixed point is the origin. Okay, each point of the original figure and its image are the same distance from the center of rotation. So, like for example, C has to always be over 1 and over 1 and up 5 or something along those lines. Well, this time it's 1 and 5. It's still the same distance away. It's 1 square this way, 5 squares this way. Same thing here, 1 square, 5 squares. They have to be the same distance from the origin every time they're rotated. So this is a 90-degree rotation, and you'll notice that A and C are the right side. They become the bottom of the shape. And B and C are kind of the left side, like it's slanted. Left side slanted, sort of. They become the right side slanted. And AB is at the bottom, and it becomes the left side. So kind of just had to picture that. But one of the easiest ways to know how to do a rotation is down here. Now, this is similar to reflections. You just have to keep in mind that what we're talking about are the original points right here, the original coordinates. Any of the original coordinates, A, B, C, we could put into this right here, and we could rotate them by doing this. In other words, the y coordinate now becomes the first coordinate. So, and I'll give you an example here in a second. And the x coordinate moves to the y coordinate spot and changes signs. So, for example, let's use point C. Okay, point C up above is at -1, 1, 2, 3, 4. Oh, I said 5 earlier. It's 4. Sorry, my bad. So -1, 4. Okay, that's the point. But when it's rotated, what's going to happen, does it make that a better 4? When it's rotated, what's going to happen is, okay, that 4 is now going to be here. So the y coordinate, whatever that y coordinate is of 4, it's going to move into the x coordinates place, okay? And the x coordinate is going to move into the y coordinates place and change signs. So that -1 becomes a +1. So now let's check and see if that's where we are. So from the origin, let's go to, this says 4, 1, 1, 2, 3, 4, up 1. There's our C prime. So it works. And it would work for every point. So this is a pattern that you're going to want to use and remember. Okay? And below this in your book, if you've written that, that's fine. But this is for 90 degrees clockwise, and you're going to see this occasionally, 270 degrees counterclockwise. This rule works for both of those. Okay, the next one we're going to talk about is 180-degree rotation. Okay, 180 degrees means it has gone a full way all the way around, or not all the way around, halfway around a complete circle. Notice it's a straight line right here, whereas this one had that 90-degree angle right there. Okay, so it's a 180-degree rotation. So notice the A stays closest to the origin, as it should, because remember the distances have to be the same. The B now just rotates where the A and B was on bottom, now A and B is on top. C was on top, and now C is on bottom. So it's almost similar to a double reflection. And it's even worded this way. So our XY coordinates of A, B, C, here's what the new coordinates are. The X stays in the X place, it just changes signs. The Y stays in the Y spot, it just changes signs. So let's check it by doing point B this time. So point B is 1, 2, 3, so -3, +1. Okay, and when we follow this rule, I'm going to change the sign of X. Well, this says opposite of X. Well, my X is -3, so the opposite of that is +3. And this says the opposite of Y, so my 1 is +1, so this Y becomes -1. Now let's check and see if that is where B prime is. So 3, -1. So start at the origin. 1, 2, 3, -1. Exactly. Okay. Now this is for 180 degrees clockwise or counterclockwise. It doesn't matter because if you go to the left counterclockwise or to the right, you end up in the same place. Okay. The next one we're going to talk about is a 270 degree rotation. This will be 90, you know, a fourth of the way around. Half the way around is 180, and 3/4 of the way around is 270. Again, this is clockwise. All of these are clockwise rotations. Just keep that in mind. All of these are clockwise. So here's our rule for 270 degrees clockwise and 90 degrees counterclockwise, because counterclockwise would be going this way 90 degrees. We go back 1/4 of the way. Okay, here's our rule. For every X and Y coordinate, like for the coordinate or ordered pairs of A, B, and C, we're going to do this. This time, the Y coordinate is going to be put in the X coordinate spot, and we're going to change the signs of Y. The X coordinate will be put in the Y coordinate spot, but we'll leave the sign the same. So let's take point A this time. No, let's not, because they're both ones. Let's take point C again. So we're going to take point C, and point C is -1, 4, which we've already done that once. Okay, and this time, okay, my Y coordinate is 4, so it's going to go right here, and I'm going to switch the sign. So instead of a +4, I have a -4. And my -1 is going to go where the Y coordinate goes, and the sign is going to stay the same. This means leave the number alone, just move it into the Y spot. This means the opposite of Y. So I have a +4, so I have the opposite would be a -4. Let's check and see if that's where we are. So starting right here at the origin, 1, 2, 3, 4, -4, -1, and it works. Okay, so there's the rules for that. I hope you copied all that down because this page is going to be very important to you. And if you didn't get that down, you can always rewind the video and pause it and watch. So we're going to do a couple of examples down below here, maybe, if I can get this to move. Okay, so here's our examples. I'm going to let you guys, you just can look through that. Notice it's telling you the original vertices of a triangle, and then graph the figure after a clockwise rotation of 90 degrees, and then give the new coordinates. So here's the original figure, here's the rotation, and here are the new coordinates. Okay? All right, let's go ahead and flip over to the next page, and we're going to do an example together, and that'll be it for the video. Okay, so we're going to turn to top of page 478. Okay, and we're going to do this very top picture. Quadrilateral MNPQ has the following vertices. So let's graph these. M is at 2, 5, so 2, 1, 2, 3, 4, 5. Here's M. Okay. N is at 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There's N. P is at 6, 1. 1, 2, 3, 4, 5, 6, 1. Okay. And Q is at 2, 1. So 1, 2, 1. Okay. So we don't have a rectangle. We have a trapezoid type figure. But it's a four-sided shape, so it's a quadrilateral. Okay. All right. it's telling me to graph the figure and its image after a counterclockwise rotation of 270. Okay, counterclockwise rotation of 270. So if we go back, bear with me, if we go back to this page right here, and I said this was a 90 degrees clockwise or 270, we're going to use this pattern right here. So we're going to use the y negative x. So let's go back to 478 and just know we're going to use y negative x. So my ordered pairs, x, y, are going to become y and the opposite of x. Okay? So I'm going to do those first. I'm going to do those right over here. I'm going to do m prime, and I'm just going to take these points, and I'm going to put my y, which is 5, I'm going to put that in the spot for x. And then my x is 2, but I need the opposite of x, so I need negative 2. Okay, and then I'm going to do n prime, same thing. My y is 4, so it goes here. My n is 6, and I need to change the sign. My x is 6, sorry, not my n, my x is 6. Okay, my p prime, well, my y is 1, my x is 6, and I need to change the sign. And my q prime is, my y is 1, so I'll leave that. And my x is 2, and I'm going to change the sign. Now I'm going to graph these 4 points. I like this. For me, rotations are hard just to do. I have to use this and then graph. So now let's graph. So 1, 2, 3, 4, 5, negative 2. Okay, so there's my m prime. N prime is 4, negative 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And notice if I'm going 90 degrees clockwise, okay, the top of my figure should become the side, and that's what's happened. The side should become the bottom should become the left side, and the left side should become the top. So let's make sure we keep doing that. P prime is 1, negative 6, so 1, negative 6. That's P prime. And Q prime is 1, negative 2. Now let's connect it and make sure it kind of looks like we rotated it. And normally what you can do is you can rotate your book and you can look at it that way. And it should look the same. Notice how it'll be like a flag and it's 2 spaces away from the Y. Well, as we rotate the whole thing, it's still 2 spaces away from. Picture that whole thing like a pinwheel rotating. It's 2 spaces away. This side is 1 space and this side is 1 space because the whole thing has to rotate. Okay? All right. I would like for you to try the problem down here, if you can. It's 180 degrees. It's a triangle. I'll graph the first points for you, and you do the rotation. So x is 3, negative 1. 1, 2, oh, excuse me. 1, 2, 3, negative 1. So there's x. Y is at 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, and z is at 1, negative 5. So 1, 1, 2, 3, 4, 5. So there's x, y, z. And we're doing a 180 degree rotation. So x prime, y prime, z prime. And remember, 180 degree rotation means that your xy coordinates, all they do is just change the signs. So I'm going to give you that much. So change the signs of each of these. I'm going to do the very first one for you. So 3 should become negative 3. And negative 1 should become positive 1. So that's the first one. Do the other two, graph them. They should end up over here because that is 180 degrees. So your shape should end up over here. The bottom should be the top should be the bottom, and check and see if you're right.